Welcome dear students. This is lecture 8 of module 4. This is magnetic testing under AC condition. Till last class we have studied about different method of testing magnetic parameters with DC supply. That is method of determining magnetic flux density in ring specimen, then flux meter, ballistic galvanometer, then determination of BH curve and hysteresis loop. Everything we are done using DC supply. So next we are going to study about magnetic testing under AC conditions. Whenever a piece of magnetic material is subjected to AC current, then there exist two losses. One is hysteresis loss and another one is eddy current loss. So these are the two laws which occurring in an magnetic material if you are applying an AC current. Since AC is frequency dependent, these two losses will be generated. These two losses are known as iron loss. So the two main factor which iron loss depend is frequency of alternating field and next one is magnetic flux density. In case of DC supply, depends on magnetic flux density only, but in case of AC supply, it depends on frequency as well as magnetic flux density. This is the graph of losses versus flux density, which will be different for different material. Iron loss will be different for different material corresponding to same flux density. So question may be asked like, explain the separation of iron loss, or what are the different types of iron loss with this derivation. There are two types as already mentioned. Hysteresis loss. For a given volume and thickness of laminations, these laws depend upon frequency and flux density. As per Steinmetz formula, hysteresis loss is eta F B max raised to K watts per meter square. You need to study this equation by heart. This equation you have studied in transformer also. Hysteresis loss in a transformer. Similar to that the hysteresis loss in a magnetic material is given by eta F B max raised to K. Eta is hysteresis coefficient, F is the frequency, Pm is maximum flux density and K is Steinmetz constant, which vary between 1.6 to 2. And for transformer we know it is 1.6, but practical value of K is taken as 1.67. So for the given specimen of thickness T in certain volume, it is given by hysteresis loss is KH F B max raised to 1.67. So what is this KH? So we can write this equation as hysteresis loss is equal to KH F B max raised to 1.67. KH is same as eta. Eta is the hysteresis coefficient, or another name is hysteresis loss constant. F into B max raised to 1.67 watt. This is the hysteresis loss. Next about the eddy current loss. Eddy current loss is mainly due to the circulation of eddy current. The eddy current loss per unit volume for given lamination is given by 4 Kf square F square B max square T square by 3 rho, where Kf is form factor for alternating supply. We know 1.11 is the form factor. So Kf is form factor for alternating supply, F is the frequency, Bm maximum flux density, T is the thickness of lamination and rho is the resistivity. So using this equation you can able to find the eddy current loss. And for a given volume and thickness, you can group the constants as 4 by 3 rho and T. These are a constant parameter. That is 4 is a constant, thickness for a particular material is constant, resistivity of a particular material is constant. If you are taking for a particular material, 4 T square by 3 rho is constant, which can be replaced as KE, eddy current loss constant. KE is eddy current loss constant. Remaining terms are KF square, F square and B max square. Okay, so eddy current loss is KE, KF square, F square, B max square for a particular material having volume, thickness and resistivity constant. then the total iron loss can be written as hysteresis plus eddy current loss, where this is the equation for eddy current loss and this is the equation for hysteresis loss. Thank you.